Good afternoon, everyone. And if you're joining from other parts of Canada, good morning, everyone. Welcome to, and our today's topic is deep learning for intrusion detection in emerging technologies. And to speak on this topic, we have Dr. Neto from, from NRC. Dr. Neto, I welcome you to the webinar today.
Okay.
Yeah, and before we get into your slides, I have your introduction, but I think I wouldn't do the justice if I read the introduction. So why don't you introduce yourself?
Okay. Thanks, Sumit. So pleasure to be here. So hi everyone. I'm Neto, Euclides Neto, and I'm a research associate with the National Research Council Canada, part of the digital technologies team, and more specifically the cybersecurity team. So I'll start off by sharing my screen. Can I go ahead?
Yeah, sure. The floor is all yours.
All right. Thank you. All right. So hello everybody. Like I said, I'm Neto, Euclides Neto. I'm a research associate here with the NRC, National Research Council. And the goal of this presentation today is for us to talk a little bit about deep learning for intrusion detection in emerging technologies. So let's get started. This is the agenda for today. I'll just make a brief introduction on the topic and give a general context on where we are right now in terms of the cybersecurity aspects. And then I'll talk about the goal of this presentation, move on to the background, talk about the solutions, the state-of-the-art solutions. And finally, and in my opinion, maybe the most important part of this presentation, the open challenges. So basically try to define what we have going forward, right? And finally, I'll just conclude the presentation. So nowadays, we have new ways, new communication paradigms that bring a lot of value to our businesses, operations, basically, right? So, for example, when you think about cloud computing, for example, or Internet of Things, we have so many new possibilities of providing services in different sectors to the society, and it's all great. It's all very beneficial in so many different ways, right? And when you think about emerging technologies in this sense, basically what we have here is technology that can simplify business operations in so many different ways. So this is all great. We have many benefits there, but at the same time, there are many challenges. And these challenges, they are, again, operational. They are specific to each business, to each sector, actually. But then cybersecurity is a big concern here. In the past few years, we've seen an increase in cyber attacks, that cyber attacks are becoming more sophisticated, more complex, and the volume is also different, right? So we are moving forward with the development of new technologies, but also these threats are becoming more difficult to deal with. Ultimately, these threats, they can have negative impacts in multiple sectors. So we think about healthcare or transportation or finance or so on. We can have different consequences of these attacks, and we need to make sure we are protected against them. In this sense, in this context, we have what we call intrusion detection systems, IDS, which basically we use to detect malicious activities, and more specifically, we use to detect intrusion, right? So anything that is out of the ordinary, that is abnormal, and any unauthorized access to our systems, that's what we want to detect here. There are different ways of detecting these attacks or this malicious behavior. So we have more traditional ways to do it. We have we have like new technologies. We have complex systems that are able to do that. And in the past few decades, actually, we've seen deep learning, or DL, I'll call it DL many times in this presentation, demonstrating a promising performance in IDS, actually in many different sectors, right? You see deep learning applications in so many fields, like agriculture, transportation, and so on. And it's not different in cybersecurity. We have such a big potential here to solve complex problems, and then we are already seeing some of these good results out there. Conversely, there's two critical limitations, right? We see like these important researchers in AI every now and then talking about the limitations of AI right now, the challenges we have going forward, what we need to do, the problems we need to solve, and it also applies to cybersecurity, and it also applies to intrusion detection. We are seeing the results overall. It's still a challenge to deploy these systems in the real world, in a real topology, so to speak. So that's still a major obstacle there. And then when we think about emerging technologies that are new, there are something that we are considering right now. We still need an in-depth analysis in order to leverage those systems and provide a better protection to our resources. So basically, the purpose of this presentation here is for us to go over recent IDS solutions, and more specifically those that use DL, deep learning, in the context of emerging technologies. So we'll discuss these existing works, some of their highlights, and also try to shed light on the open challenges and what we can do going forward. All right, so moving on to the background now. And first of all, talking about intrusion detection systems, IDS, it's very important here to make a distinction between blue teaming and red teaming. So blue teaming, you're talking about defensive posture, defensive capability. So let's identify the threat, let's protect the system, let's respond, let's recover, while red teaming is much more of a offensive side of things. So basically what we want there is to understand the vulnerabilities we have in the system and then improve the security posture. But then going back to the blue, we have many activities, many different things that we need to do in order to protect our system. And intrusion detections is a critical component there, is a major activity to conduct, right? There are different ways of doing this, of course, there are different methods. We have more traditional methods, we have rule-based methods, we have many applications, many solutions using machine learning, using deep learning. But overall, that's the purpose of IDS, right? To pretty much detect something that is unusual that is happening in our topology, in our system. Okay, so now moving on to the emerging technologies. And by emerging technologies, what we don't really mean a technology that they're new in terms of concept, because some of them there are actually there are solutions for them, you know, like I don't know, like people are working on them for the last so many years, and they're not necessarily new in terms of concept, but there are many companies and organizations right now moving towards the adoption of these technologies. So and now we are just like taking off in terms of actually using them, and we are facing the challenges, right? So first of all, we have cloud computing, which is basically a computing paradigm where we have this interaction between remote servers and users, and different services being provided in different ways, right? There's so much to talk about cloud computing, but then with this general and broad definition here, we have different components to cloud computing. We would have application, we have platform, we have infrastructure and hardware. And here specifically, we have what we call a shared cybersecurity responsibility, which basically the cloud provider is responsible for some aspects of the security, while the user is also responsible for other parts, right? So it's different to secure, for example, hardware and application. And it's also important to mention that for each component here, we do have some areas of potential vulnerabilities, not necessarily vulnerability, but areas where we potentially can have a vulnerability, and it's important to watch for those areas, right? Next, we have edge computing, which is related to what we have in the cloud. So basically, we have a layer that connects the cloud to the end user, end devices. Basically, we have a closer access to the services. But then, of course, there are many benefits here. We have the real time or response at a short time. But then we also have the challenge of orchestration and management of all the data and computing services, right? And once again, we have potential vulnerabilities in different ways, and that's something that we need to watch for. The Internet of Things. Basically, here we're talking about mostly lightweight devices that connect to the network, connect to the internet, and provide different services in different areas, and produce and consume data, produce and consume, providing different services, of course. And then they are used in different sectors. For example, we have Internet of Vehicles. We have Internet of Medical Things. You have many, these are just examples. We have many other examples. And again, we also have potential vulnerabilities here. Moving on to the networking side of things, we have software-defined networking, which is a specific way of controlling or orchestrating the network. And we have different components like infrastructure layer, control layer, and application layer, where developers can have a better control over what happens inside of the topology, inside of the system, right? And they have specific protocols, they have specific way of operating, and consequently, there's also specific vulnerabilities that need to be considered here. MEC have multi-access edge computing, which basically here are talking about mobile connections and cellular networks, and usually a great number of devices connected and services provided. So again, that's specific protocols as well. So that's something that we need to consider in terms of vulnerabilities. And finally, we do have industrial control systems. Basically here we are talking about interaction between the traditional topology that would have like a traditional TCP/IP system, so to speak, and devices or systems that actually control different things in the industrial environment, right? So for example, we have programmable logic controllers, so the PLC and many other things, and specific vulnerabilities to this particular emerging technology here. Okay, so in terms of the attack surface, what we have here is for every single component in this tree, we would have different areas to consider in terms of vulnerabilities. So for example, in cloud computing, we would have application, platform, infrastructure, as I mentioned before. But then if you want to consider application as an example here, this is a block that needs a lot of work to be done, right? Securing applications in the cloud is a hard work, it's very complex. Similarly, securing the platform is also something very important and complex, right? So if you consider like every single block here, you see there's a lot of work to be done in terms of securing them, right? Not only in terms of IDS, but in terms of security, generally speaking, in terms of blue teaming as a general concept. Okay, so moving on now to the solutions. And whenever we develop a new system, a new model that is able to protect them, just an example, an IoT system, for example, we want to use this deep learning model that's able to detect attacks in IoT. We need to have a way of measuring if this model is a good model, is an efficient model. And then what I mean by efficient is there are many metrics to consider that, right? But I'm just saying it's a good model, let's put it that way. So in order to do that, of course, we can establish our own topologies, our own systems, and perform the experiments, collect the data, and so on. However, what we need is a way to represent a real environment, a real operation, while skipping the part of deploying a comprehensive network, right? Because it's not easy, it's difficult, there are many things involved. So that's where datasets are so helpful. So these benchmark datasets Basically, what they do is they collect the data from real infrastructures with attacks being launched and everything, and they try to replicate what would happen in a real environment. Then the authors, the researchers, they disclose, they share this information with the whole community, and then the community can test their own models, right? And it's highly valuable to evaluate the deep learning models and whatever model you have actually. And over the years, we've seen this has been published, being developed. So in 1999, we saw the KDD Cup 99 being published, and ever since we have many different datasets focusing on different aspects, different technologies, different attacks, and up until 2024, we have had many IoT and right enterprise datasets and so on. It's important to emphasize here that we do have, of course, other datasets in 2024, published in 2024, and other datasets also in 2025. But it's also important to emphasize here that we still need more datasets, right? These datasets are great. We are using these datasets to evaluate our models, but then there are new requirements that we need to include in these new datasets that we need to develop. So, for example, new services are being provided, new protocols are being created, and the security aspects of those protocols, in order to, if you want to develop a model to protect the system, you need to have it represented somewhere, right? So a dataset for those new technologies are also important. So we still need more work to do in terms of the datasets. Okay, so talking about cloud, edge, and MEC more specifically cloud, we have specific, for example, specific technology side of the cloud environment. There are very specific. So, for example, Kubernetes, right? And the datasets, they may not include Kubernetes logs, for example, or whatever other cloud technology you may consider. However, they include relevant data that can be used by, or what is represented in a way that is similar to what a cloud operation would be. So that's what we see authors doing. So that's why they leverage these data sets. But then when you go to IoT, that's a different story. We have many data sets right now published focusing on IoT more specifically in different areas, right? You have data set with extensive test beds, so CIC data sets, for example. We have IoT data sets. We have IoT with, for example, the Edge IoT data set. So these are all super valuable resources that they are very useful, right, in many different ways. For SDN, for software-defined networking, we do have good data sets. So, for example, the SDN data set is widely used, and they bring a lot of value to SDN researchers, more specifically in security, right? Okay, so moving on now to the applications. And here we have a table that summarizes a few words, only a few words, and represent the goal, the deep learning model used, the data set, the attacks, and so on. And all of them are focused on cloud computing. So in terms of deep learning, of course, we're considering different models. We're considering feed-forward networks, CNNs, RNNs, generative adversarial networks, autoencoder, and so on. And for cloud, that's very interesting because scalability is something very important when you think about cloud. You think about how to deploy our services and how we can scale businesses and so on, right? Services in general. But it's also important to consider this in security. So just some works focusing on the scalability of IDS, or scalability of the let's say readiness of IDS for scalability. And another very important thing here is this false positive rate. So we do want our systems to be able to detect the attacks and to classify the attacks properly, but then we also don't want the systems to label a lot of benign traffic as malicious, right? Otherwise, we would end up with a lot of data to analyze afterwards. So there are some authors focusing on those aspects and generating realistic data as well. So like I said, data sets are important. There are some aspects that might not be present right now in the data sets we have. So there are some generative approaches that use generative models to do that. And that's overall what has been done in cloud computing, right? Moving on to edge computing, we do have a similar approach, basically. So there are similar related systems, but then here, the interesting thing is we do have some real-time concerns, like concerns for the temporal aspect of IDS and how it relates to the whole cloud stuff. So basically, some authors, they do use a different representation of the data in order to speed things up, which is interesting. And another big concern here is flooding. So they're basically trying to understand how these attacks happen. And because here we are talking about multiple devices connected to the system, right? So how can you actually detect, analyze, and understand how floods happen, and how can we detect and mitigate them, basically? Moving on to IoT, we do have specific areas to consider. So, for example, specific applications, I mean. So, for example, Internet of Vehicles. In the Internet of Vehicles, for example, we have the concern of intra-vehicle communications, meaning the communications of the internal components of a car. So how can we actually detect if there is an attack happening or something unusual happening? But at the same time, we also have the cars communicating, right? So we need to make sure this communication is secure. And a third point that I would like to mention is transfer learning. So we do have different IoT applications, we do have different systems, and can we actually leverage the knowledge from one system and improve the performance of IDS in another IoT system? So that's another interesting area of investigation that people are working on. And back to SDN, as like I said before, and here we are talking about very interesting, powerful, and specific technology, and address some specific aspects related to the protocols they use, right? So how can you make the intrusion detection robust, considering the specific scenario that we have inside of SDN? We have MEC, as I said, here, again, we have many devices. We expect many devices to be connected to the topology, so that's what we consider here. And there are some concerns, for example, in terms of federated solutions. So how can you protect federated approaches and in a complex and diverse system, right? But then in terms of anomaly detection and intrusion detection, there are many things that, of course, can be reused from different technologies. And finally, ICS. We have here is a very interesting and specific topic, because we do have the concern of, okay, let's identify what's happening in the network side of things, but then we can also leverage whatever happens in the operational environment and try to connect those two set of group of features in order to improve our detection, right? So there's a different set of tools that we can use to do that, and authors are using different methods and combining different deep learning models as well. So yeah, overall, that's what has been done. Okay, moving on now to the open challenges, and I consider this to be the most important part of the presentation. So when you consider deep learning, the use of deep learning in IDS, and more specifically in emerging technologies, we consider have three main pillars when it comes to what's next, what can we do going forward. And these are business adaptability, and then under business adaptability, we would have environmental awareness and holistic intrusion detection, trustworthiness, and we would have explainable identification, recognition, robustness, and finally, operationalization with deployable countermeasures and continuous detection improvement, and finally, generalized discovery. So in the next few slides, I'll go over them and just talk a little bit about these challenges and what can be done next. Okay, so starting with business adaptability. And what we mean by business adaptability is we do have models that perform really well in control environments, and this is great. We do have good numbers there, but then can we reproduce the same performance in a real environment? And of course, it depends on the environment you're talking about, different sectors, different companies, but then how can you actually use this model in a real setting? Right? So that's the challenge here. And first of all, we have the as future steps, as research lines, we have the development of simulation tools and data sets. Yeah, and it's important because there are some constraints in real applications that might not be present in some of the control experiments. So for example, consider we want to deploy a model, but then we have some constraints in terms of data access, for example, right? There are some policies that prevent our models to use from using the data, or even access to the traffic itself. So the models, like it's very important, it's critical actually for the models to be compliant with the rules. And this is something to be considered in simulation tools. The other thing is metrics and benchmark frameworks. So if you consider, for example, supervised learning, we have accuracy, we have F1 score, have recall and precision, and you have many other metrics that you can consider here, which is great. But then there might be some metrics specific to a business that are very, very important, right? So for example, maybe some businesses, they might require short response time. Maybe other, in a different environment, you need a simpler model. The model cannot be complex. So we don't know, it's specific to each business. And these also are parts to be considered. And finally, and business operation, which is not very different from when if you consider, for example, healthcare, we can have an analysis of the network and check for unusual behaviors or unusual patterns to identify an attack. However, even if you don't see, based on the complexity of the cyber attacks, even if you don't see an attack there, the medical personnel can take a look at the devices or the data and identify there's something unusual happening with the data, right? So this might be an indication of something unusual happening behind the scenes, and leverage this knowledge of combining whatever we have there and whatever I have here can empower IDS to, and this is in all sectors basically, right? So this can empower IDS to be stronger, more robust, and more efficient. Moving on to holistic intrusion detection. Here we're talking about a more comprehensive approach to protecting our systems. So basically, consider, for example, a company rely heavily on cloud computing, for example. But then this company also has a large IoT testbed, also presence in the IoT sector, let's put it that way. And then also they have ICS systems or components, or they have many of those emerging technologies. So the first point here that we have is the development of data sets that incorporate this multiple emerging technologies operating simultaneously, so that having insights from one side could help the other side as well. So, and that's what we have in the second point here, collaborative intrusion detection. Basically, if you detect something in the IoT side, it can help the IDS in the cloud to see if there's something happening, right? So, and then at the end of the day, we can have ultimately a centralized way of identifying and receiving this inputs for different subsystems, let's put it that way. So that's 2 points. But then, of course, these are 2 important points to consider, but then there are other points to consider as well. The next pillar is trustworthiness. And here we are talking about, can we trust whatever the deep learning model says? Can you really use the information, the inputs they provide to the analyst, and then move on and do things with that? So, and first of all, we have the explainable identification. And here, putting it in a more general, generic way, and we're talking about the relationship between the analyst and the the deep learning model itself, right? So how can the deep learning model help the analysts go over this potential threats? So it's not only a matter of being able to explain, like to explain the rationale, or to have the right rationale, to have the right reasons for classifying things, but also being able to convey the message of, okay, this is what's happening, and then be efficient in that, right? So this is a challenge not only in cybersecurity, of course, but this is a challenge here as well. And finally, reverse engineering of malicious behavior, so that we can help have a better understanding of the threat and how we can mitigate it, detect and mitigate them. In terms of recognition robustness, we need our models to be robust. We need our models to be efficient and ready for inputs, different configurations, and it's important to consider a continuous update and correction. And also strategies to gradually integrate and evaluate models, right? Something very important, because like I said before, the systems, they evolve, new protocols are developed, new requirements are there, are in place, and then in order to work with all those requirements, all those this new environment, so to speak, we need to have these models able to adapt. And finally, we have the third pillar, the operationalization pillar, which is here we're talking about the actual use of deep learning in the real world, right? So talking about deployment, to talk about how can you actually use it in a continuous way. So first of all, we have the deployable countermeasures, which basically different businesses, they might have different priorities for assets, and having this knowledge is also important when you think about cybersecurity. Not only that, also it's very important to be business aware, and I mentioned that a few slides ago about being compliant with the rules, and that's critical, right? So the model can be very efficient. The model can be have a really good performance, which is great, but then it also needs to respect all the rules, be compliant with the organizational policies, and then again, performance evaluation is something that is very important, because performing really well in an environment might present different performance in different environments, but not only that, the metrics of different environments can change. Something that is important for organization A might be very different for organization B, right? So that's something also to consider. The next point is the continuous development, the continuous detection improvement, sorry. Here we have the threat modeling in autonomous evolution, which is challenging to do, but then that's something that is an open research field. And finally, we have generalized discovery as another challenge, because if you do have a model that is very efficient in a particular system, how can you just go and using under the system, right? How can you train it in a way that is will perform well everywhere it goes? Well, not everywhere, but at least some different places, some different environments. So that's another challenge. Okay, so in conclusion, deep learning has demonstrated promising performance in the context of IDS in the past few years, and there are many interesting works already published. There are many interesting works to be published in the next few months, in the next few days, even the next few years. So there's a strong community working on very interesting topics to improve cybersecurity and IDS more specifically. And still, we still have open challenges, right? So there are complex challenges that we need to solve, like complex issues that we need to address, and areas that we need to consider, and potential research lines, right? So this presentation here was basically a brief description or a brief analysis of the works and the general concept. But then If anybody wants to get more details on all the works and data sets and everything, we have published a survey paper recently. So all the information contained in this presentation is available there as well. Okay. So I think that's it for me. So thank you so much for your attention. Again, if you have any questions, please feel free to ask. I will be happy to take them. But then if you don't have any questions or might have questions later, my email is there. So feel free to reach out, and I'll be glad to get in touch. Thank you.
Thank you, Neto, for this insightful presentation. And of course, your presentation solidifies the belief that how important how important are the data set for the research and innovation in the space of cybersecurity. With this, we'll move on to the Q&A session, and let me just quickly see if we have any question and answer. It seems we do have a lot of them. So let's see. Okay, I think we should be able to take all of them within the remaining time. So I'll just read out the first question. How can I combine the cybersecurity feature with the business feature to detect attacks?
Okay, so yeah, that's a good question, because like I said before, right? We have when you take a look at the network traffic, for example, and only the network traffic, we do have access to valuable information to detect the patterns and everything. But then if you have the understanding of how the business operate, we can go maybe we could go beyond that and then just leverage this particular knowledge, domain knowledge, and then infuse it into our system, right? So maybe, for example, if you think about complex attacks like APTs, for example, maybe this insights might be very important to detect those attacks, right? So I think that's the way that we could go and combine them.
Okay. Thank you. And this is from Dr. Hamida. What are the cybersecurity constraints in the wireless system, like industry?
Yeah, that's a very good question. That's a very good question. So there are many challenges there when you think about the whole ICS, right? So thinking specifically about wireless, there are different works focusing on how can you use different I don't know, cryptography algorithms, for example, right? So this is not necessarily something that would go necessarily related to IDS. It goes actually beyond. We have IDS challenges there, but then we also have all the areas of the blue teaming activities, right? So definitely that's a hot topic. There are new technologies coming, being developed right now for particular applications, like for example GPS, right? So that's a big concern in some specific fields, and definitely an open challenge. So yeah, thanks for the question.
Okay. Thank you for the answer, Dr. Neto. And our third question is, what is the importance of large language models for IDS?
Oh, that's a very good topic. Yeah, that's a very interesting topic, actually. So in the past few months, I would say, maybe past few weeks, we've seen a lot of works being published in the context of using LLMs in cybersecurity. And it is just great. This is great. I mean, LLMs, they bring a lot of value. Of course, they do have limitations. They do have things to be improved. But then I think they bring a lot of value in the way we interact with the systems, right? So maybe they might bring insights in terms of how if we do have an understanding of a background or a database, let's say, of valuable cybersecurity information that we describe how our systems work, LLMs can leverage this knowledge and maybe provide us some insights in terms of how these deep learning models can maybe engineer new features, or maybe have a combined version, a combined IDS version that can leverage both ways. So I think it's great, and there's a lot more works coming in the LM field, and I think that's just great to see this new direction.
There's another question that I'll read out from Dr. Hamida. Do existing studies address the cybersecurity constraint from the control systems and the communication system separately, or there should be a joint framework?
That's an interesting point. Questions, and my personal opinion here is I think we need to like explore different ways of doing this. So basically, I traditionally we are focused coming from working on different apply machine learning models and deep learning models to classify attacks in the network. And we come from a background that we just apply and understand these attacks, but then also understanding the behavior of these devices separately without the networking part is also something that can be beneficial, right? So if you ask, for example, investigating them separately, I think it would be beneficial to understand both sides. But then maybe if you have them combined, they could be also beneficial, right? Of course, it depends on the environment, it depends on the system, it depends on the specific application. So yeah, I think it's again another open question, very interesting to dive into.
Okay. Thanks. Thanks, Dr. Dr. Neto for this. With this, we'll go to another question on the business knowledge. How does the business knowledge helps in IDS?
Yeah, like I said, right? So, well, this is a little different now because you can use the information of the systems that, for example, in healthcare, in ICS, as mentioned in the question, to leverage to improve the performance of IDS. But then, in terms of the business knowledge, I suppose is much more something related to the compliance with how the business operate. So, for example, if you have a data set that you cannot use, then you must not use that data set, right? And you need to be compliant with the rules of the organization. And not only that, if there's a requirement for explainability, transparency, we need to be aware of that. We need to provide it, right? So I think it's one of the main challenges, and then one of the most important aspects of deploying systems, not only IDS again, cybersecurity in general, one of the most important challenges of deploying systems in the real world. So yeah, thank you for the question.
Thank you, Dr. Neto. I think we just have a couple more questions, so I'll read out the next question. Based on today's presentation, what do you see as the biggest obstacle for deploying deep learning based IDS in your own environment?
Yeah, I think it's a very good question. It's challenging because the systems we have nowadays, they're getting more and more complex, right? So we have on one hand, it's really good because you have new services and new possibilities, but on the other hand, it's difficult to protect them, right? So there are challenges in terms of performance, for example. We have this discussion about LLMs, and LLMs are great, but then can you really afford running an LLM to protect our system? That's a question depending on the organization, right? So can you really use it? So, and then if you use a limited system, a small system, can you really trust it? And then is it really, if you have a transparent model, does it really present that good performance? So I think these are all questions. It's hard to tell what's the biggest challenge. I think these are all important aspects to consider. And then that's why I think it's so important to have a strong community as we do have to collaborate in different sectors, different areas, right? And then collectively, we can build a stronger cybersecurity posture for everybody.
Okay, thank you, Dr. Neto. I think we do have a lot of interest coming from people who joined us today. So with this, we come to the last question for today's session. Which emerging technology, cloud, edge, IoT, etc., do you think poses the greatest challenge for intrusion detection, and why?
Wow, that's a hard question. That's a very hard question, and it's hard because I think all of them are they are all related, right? They're not separate. They're not they are simply they kind of depend on each other. So it's kind of hard. But then if I could say one that I could think of right now, I would say IoT is a big challenge. because IoT is so incredibly useful in so many different ways. But then the specific requirements of an IoT device to be light, to be portable, to be all of that, makes things complex, right? So we do have some studies on profile, for example, IoT profiling, and we see some profiles changing across different environments. And then when you go to IoT, maybe you have like a simple, I don't know, like a simple small device that a speaker, for example, or a speaker would be even more complex, right? But something like a light bulb, for example, with a very specific profile. And then when you go to the cloud computing with a high-end server, a completely different profile, and of course, completely different demands, right? Completely different requirements. So I think IoT would be a big challenge. Is a big challenge, but at the same time, that's something very exciting, right? Because you have so many possibilities with this technology.
Thank you, Dr. Neto. With this, again, we come to end of today's session. It was certainly very insightful, and I'll say thank you, Dr. Neto, for sharing your knowledge and giving us your time. It's a goodbye from the Canadian Institute for Cybersecurity, and you all have a good rest of the day.
Thank you.
Thank you.